When you think about AI today, the stuff that writes poetry, makes incredible art, it's easy to think it just appeared. But that's not the story at all. The real story is this 70-year-long drama. It's really a tale of two competing ideas, two completely different philosophies, battling it out for what it means to be intelligent. So let's get right into it. Okay, it all kicks off right here, 1955. And you've got to read this quote. It's just so incredibly ambitious. The idea was that every single aspect of learning, of intelligence, could be described so precisely that a machine could do it. I mean, this wasn't just some dry research proposal. This was a gauntlet thrown down. They were essentially saying, the human mind? Yeah, we can build that. And that single bold idea is what launched the entire field. All right, so here's how we're gonna break this down. We'll look at 4 big acts in this play. First, that initial spark, the Dartmouth conjecture. Then, we'll dive into the long reign of what's called symbolic AI. After that comes the big twist, the deep learning revolution. And finally, we'll see where we are now, in what's being called the age of agentic AI. So, let's jump in our time machine and head back to the 50s. This is where it all began. That 1956 workshop at Dartmouth, that was the official starting pistol. And what came next was just this explosion of optimism. I mean, for almost 20 years, people were blown away. You had computers solving complex algebra, proving theorems from geometry, stuff that was supposed to be uniquely human. Everyone thought, wow, a truly intelligent machine, it's gotta be just a few years away. And all that excitement, it was built on this one single idea. The belief was that intelligence, at its core, is just a big set of rules and logic. It's like a grand instruction manual for thinking. So if you could just figure out all the rules and painstakingly program them into a computer, boom, you've created an artificial mind. And let me tell you, that one idea, it ran the show for decades. And this is where we get to the first big civil war in the world of AI. That rule-based idea became the dominant way of thinking, but there was another, totally different philosophy bubbling just under the surface. And it set off this huge debate about what the right way to build an AI even was. Basically, the field split into 2 teams, and they had these great nicknames, the Neats and the Scruffies. The Neats were all about symbolic AI. They were the top-down folks. They thought you had to painstakingly write out every single rule of logic, like handing a computer a massive, perfect rulebook for how to think. Then you had the Scruffies. They were into connectionist AI. They said, no, that's all wrong. They believed intelligence had to grow from the bottom up. You build a network of simple connected things, kind of like neurons, and it just learns from experience, like a kid watching the world. And for a long time, the Meats were totally winning the argument. Their masterpiece was something called the expert system. And these were actually the first AI programs that really worked in the real world back in the 70s and 80s. The idea was simple. You interview a human expert, say a doctor, you turn all their knowledge into a giant list of if-then rules, and you feed it to the computer. And honestly, they were surprisingly good at making decisions. This rule-based approach got so big and so dominant, you couldn't even run these programs on a normal computer. They were just too complex. You actually had to buy these specialized, super powerful computers called Lisp machines, just to have enough horsepower to run all those complicated rules. Then, in 1969, came what looked like the final nail in the coffin for the Scruffies. A book called Perceptrons came out, and it was just this brutal mathematical takedown of their whole approach. It proved that the early neural networks they were building couldn't even solve some really simple problems. And this book was a big deal. It helped kick off something called the AI winter, where funding for that kind of research just dried up completely. It really looked like the debate was over. The Neats, the rule-based guys, had won. Or had they? So time marches on. The rule-based systems had some wins, but they kind of hit a ceiling. And then, after decades of being out in the cold, the underdog, the connectionist idea, staged what might be the single biggest comeback story in the history of technology. See, here's the problem they ran into. You just can't write a rule for everything. I mean, think about it. How would you write an if-then rule to tell a computer what a cat looks like in a picture? There are too many angles, too many breeds, too much messiness. The world is just too complicated. So progress stalled because everyone was trying to write better rules, and that was never going to be the answer. The real missing ingredients were 2 things the early pioneers could only dream of. First, data. Tons and tons of it. And second, the raw computing power to crunch all that data. And funny enough,
The internet gave us the first, and the video game industry of all things accidentally gave us the second. And all of this leads us to one specific year, 2012. You can draw a line in the sand right there. This is the year that the old scruffy idea, now with a new name, deep learning, came roaring back and changed absolutely everything. Okay, so check this out. There's this huge competition every year for computer vision. And for years, people were making tiny little improvements, chipping away at the error rate. Then, in 2012, this neural network called AlexNet shows up. And it doesn't just win, it crushes the competition. Look at that drop. The error rate didn't just go down, it plummeted by almost 10% in a single go. Nobody had ever seen anything like it. It sent a shockwave through the entire field.
So what was their secret sauce? Well, it was really a recipe with 3 key ingredients. First, they had a way better model, a convolutional neural network, or CNN. Second, they had a gigantic dataset called ImageNet, which gave the model millions of pictures to learn from. And the third kind of crazy ingredient? They used GPUs, graphics cards, the same things that power video games, to do the training, which was just unbelievably faster than anything before. And that recipe, that's what started the AI boom we're living in right now.
And that revolution brings us right up to the present day, because we've taken those same core ideas that made AlexNet work, and we've pushed them even further. We're moving beyond AI that just sees things or understands things. We're now entering the age of agentic AI that can actually do things. It can take action in the world for us, make its own decisions, and handle complex jobs all on its own. I mean, just look at how fast things have moved since 2012. It's been absolutely insane. In 2017, we get the transformer architecture, which is the engine behind all the big language models. By 2022, pretty much everyone on the planet has heard of or used tools like ChatGPT. And now we're looking ahead to 2026, where the forecast is that these agentic AIs will just be woven into the fabric of pretty much every industry. And we're not talking about science fiction here. We're talking about real-world predictions for just a couple years from now. Things like banking assistants that can tell if a customer is frustrated or happy, ambulances that are streaming a patient's vital signs directly to the hospital while they're still in transit, or secure AI systems managing trillions of dollars in investments. This is AI graduating from just being a chatbot and becoming the central nervous system for how our world works. So if there's one big thing to take away from this whole 70-year story, it's this fundamental pivot. The entire field started with this neat idea that we could write down the rules of intelligence, that we could build it from the top down. But where we've ended up is in a scruffy bottom-up world where we don't write the rules. Instead, we create systems that can learn the rules for themselves from massive amounts of data. In a way, the student has finally outgrown the rulebook. And that whole journey, from painstakingly writing rules to creating powerful learners, it leads us to the next massive question on the horizon. What's next is AGI, or Artificial General Intelligence, a system that can think and learn across any subject, just like a person. But as we get closer and closer, the big question isn't really if we can build it anymore. The real question is, how will we even know when we've done it? What's the real test for a machine that can truly think?